Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called SVS number 463, Borderland by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. A cell with a diamond is part of a group of horizontally and vertically connected cells containing digits of the same parity, which is odd or even. The digit in the cell with the diamond indicates the total number of cells in the corresponding region. There may be multiple cells with a diamond in the same region, and not all possible diamonds are necessarily given. So that means, say we had an odd region going like this. And then the rest were all evens here. Obviously, it's going to be problematic here. So, okay, so say this was even. That's actually obviously problematic. But anyways, it's problematic in more ways than one. But just ignore everything else. This is an example. For the odd, this is basically an orthogonally connected region. So every orthogonally connected region, or group of horizontally and vertically connected cells, which is essentially an orthogonally connected region, which means you can go from any cell in that region to any other cell in that region just by going through edges while staying within the region. This would have 7 odd digits here. Because it's 1, 2, 3, 4, 5, 6, 7, and the rest are even digits here. So in that case, this would be 7 and 7 here, assuming that this was valid, which it obviously cannot be because of the 7 in the box, and for other reasons too. But this is an example of how the cells in the diamonds work, right? Assuming that this was like odd and this was odd here, this would have to be 2, because for the orthogonally connected region, which cannot include this because you can only get there by you can only get there by a corner or exiting the region to get there. This would then be 2 if that were the case, right? This could be connected to other things, etc., etc. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we know 8 is an even cell. 7 is odd. These are even. These are odd. So we know any diamond cannot share an edge with another diamond in the same box or in the same row or column. So we know these have to be edges here, and this one is surrounded by diamonds, so it can't be the same region as any of those diamonds because it would have to be the same counting the number. So this must be 1 and is odd, which means the ones that surround it must all be even. So these must be even. These have to be odd because, again, if they were the same type of parity, they would be part of the same region. So these are even, these are odd, which makes this even. So this is even, it must go here. These are same parities or different parities also. So are these. This cannot be 1, so it must exit out. This can't be 1, so this must exit out that way. That gives us 4 even digits in box 2, so this cannot be even here, so this must be odd. So this must go out that way to be connected to be non-1 as a region. These have to be at least 3 or 5. We have 2, 4, 6 could be there. 2, 4, 6, 8 could be there. 2, 4, 6, 8. But this cannot actually be... Okay, we have 4 evens in column 3, which eliminates evens in the rest of the column. So this rest is odd. This cannot connect to the other even in the box because we can only have 4 evens in the box. So one of these must be even, which means the rest have to be odd. One of these is even, one of these is odd. We're not sure which. This must be at least 3. 3, 5, 7, 9. So these have to be 4, because this is going to be a size 4 region here. That means this can't be 4 here. There's no 4 here. This can't be 2 or 8 because of 2 or 8 in the column, so this is 6, which means the last digit is a 2 here. So this is 2, 6, or 8 here. We have 5 even odd digits in row 3, which means that eliminates odds in the rest of the row. So these are even. These obviously can't be 7 because of 7 in the row. One of these two is even. We're not sure which. This is at least 6 digits that are connected. So this cannot be 3 or 5. It has to be 9, which eliminates 9 in the rest of the box. This is at least 3, but we don't know if it can be more, or it has to be more. So we have 1, 2, 3, 4, 5, 6. This is 9 also. It has to match. This is even, so this cannot be even because they would be the same digit, so this must be odd. This has to be 2, 4, or 6. This is 2, 4, or 6. So one of these is an 8. One of these is 7, so one of these is 7. And one of these is 4. This can't be 3, 5, or 9, so this is 1 or 7 here. Because of 3, 5 in the column, 9 in the row. This has to be 1, 3, or 5, with 1 being one of those digits there. We have 2 is one of these 2 digits, so therefore 2 has to be one of those 3. Can we have even here? I guess. Oh, But if this were even here, if this was even and even, the problem is that would count for all the evens in this box because we'd have 4 evens, right? And these would have to be opposites because, again, for every diamond, they cannot be in the same, they cannot be sharing the same parity because if they were, they would have a duplicate in the same row or column. And the rest would be odd here, which would mean this would be size 1 of the region, which doesn't work. So this cannot be 2 evens here. This must be even here, which makes these both odd, which makes this even here. So this is 4 or 6 here. We're not sure which. These cannot be the same parity because if they cannot be in the same region, because if they were, they would have to be connected. They would basically duplicate the same digit in the same box. So this must be even, which accounts for all the evens in box 7. So therefore these can't be even here. That's odd. This is then 1. This can't be 1 or 3, so this is at least 5. So this is 5, 7, 9, which means it must exit out this way. This is 2, 4, or 6. It cannot be 6 because it's blocked by the reds here and the reds here. So that means it can have only at most 5 evens in its region. So therefore it cannot be. It's 2 or 4. Can it actually... It could be 4. It just can't connect to here. If it does. This cannot connect to here because then this would also be 9. So this must be even. If this were connected to here, that would account for all the odds. But then the problem with that is these would all have to be even, but we have a guaranteed 2 in one of these. So that would make 5 evens in column 2, which is not allowed. So this cannot connect to here, which means this is even. This has to be odd, and this must be size 3. So we have to have 2 there. 3 eliminates 3 in the rest of the box. So this is a 1, 5 pair, which eliminates 1, 5 in the rest of the row. So this can't be 5. That's 3. Therefore, no 3 here. 2 can't be here because of 2 in the box. 7 then has to be here, which makes this a 9. 7 eliminates 7 in the rest of the column. This is size 1. This is even. Cannot be 4. So this is 2, 6, or 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have to have at least 1 odd here. So that would make 9. It could be less. Okay. Remaining digits in column 3. We have 1, 3, 5, 7. No 1 here because of 1 in the box. This is 4 or 6. We have 1 even, 1 odd here. We're not sure which is which. Remaining digits in row 2. We have 8, 1, and 3. Remaining digits in row 1. We have 5, 9, with 2 or 6. This is 5 or 7. We're not sure. Size 3, size 1, size 9. Remaining digits in box 7, we have 3, 5, 7, 9. No 3 or 9 here because of 3 or 9 in the column. No 7 here because of 7 in the column. So we have 2 evens here. Can we have an even here? The answer is no. Oh, wait, this could still be 6. Oops. Huh. So the answer could be yes. Hmm. 3 eliminates 3 in the column. 5 eliminates 5 in the column. Size 4 as a region, size 3 as a region, size 1 as a region. This can't be 8. Well, maybe. 1, 2, 3, 4, 5, 6, 7. Okay, it could be 8. Never mind. We know 3 is one of those 2. Okay. We know one of these is red. So it's going to connect to this part. That's 7 odd digits. We could have an 8th here. We have guaranteed 1 odd digit here. We could have 2, though. Hmm. Let's mark the border in green. This is size 1. Hmm. Remaining digits in column 1. We have 2, 4, 6, 5, and 7. Hmm. Can this actually ever be 6? I guess it could go out that way. So, yes, the answer is yes, it could be. Obviously it could be 2. Then there would be red, red, red. That's fine. What happens if it's 6? Okay, so what happens if it can't go 6 this... Well, no, it can't go 6 this way. It could go 6 that way, but the problem is it needs another blue. So it would have to go here, but then it would connect to that, which is greater than 6 cells. So can't use this one. So the only other one could go that way. But the problem is that would leave all of these as odd, which is already greater than 9 odds in the region if that were the case. So this can't actually be 6. Again, we can't connect to here. Can't be 4 down because that's 5 evens in the column. If we tried going this way or tried going that way, we have to extend one more outside of the box. We already have 4 in the box, and it would have to necessarily connect to this, and therefore would be larger than 6 as a region. And the only other possibility was that way, which forces all of these to be odd, which means this is greater than 9 as a region. So this cannot be 6, it must be 2. Which means all of these are odd, and we know we connect to 1 here. That's 2, 3. If we try to connect there, so that would be 1, 2, 3, 4, 5, 6, 7, 8. If we connect there, that's 9 and 10, which is too large. So we cannot connect there. It must be even. So we must only connect to 1 odd here, right? 1, 2, 3. No, sorry. 1, 2, 3, 4, 5, 6, 7. So we have to connect to 2 odds here. So therefore, this can't be odd. It's even, which means this connects here. So this must be 6 and 6. So we have 6 and 6. This cannot be 6 here. This then cannot be even, because if this were even, then this would be part of the same region, but it can't be 6 here and then another 6 there. So this is odd. We have 5 odds in column 4, so that means this must be even, which means this is already size 6. It must be odd, and these have to be odd here. 6 eliminates 6 there, so it's 4, no 4, 6. This can't be even, it can't be 2. Whereas the 2, it has to be here. So no odd here. We have 5 odds in box 4, so this can't be odd, it's even. So that's done as a region. Done as a region. Done as a region. Done here. This is 4, 8 as a pair. This has to be 1, 3, 5. No 7 or 9. Okay, this is 2. These are connected, and it cannot be size 1, so this must be size 7, which makes that 7, so that's 5. This could connect here. But if it connected here, the problem is you'd have 1, 2, 3, 4, 5. Okay, 2 is here, which means this can't be 2, so this is 6 or 8, which means the even has to go out this way. That means we could connect. Wait, we can't. We don't have any more evens in row 1, so these have to both be odd. So no 2 or 6 here. This cannot be 6 or 8, so this is 2. And to orthogonally connect to form a cell greater than 6, you have to connect to here. And this cannot be 8 because this can't be 8. So this is 6 and 6 there. That makes that 4. This is 8 here. No 8 here. 6 eliminates 6 here, so this is 8. The rest of these are odd. This must be odd. And this is not size 7, so it cannot connect to this. So this must be even. And this is size 5, which makes that 9. This is size 7. We cannot connect to that because it would be size 8. Therefore, this is even. We have 4 evens in box 5, so this cannot be even. It's odd. Only one of these is odd, the other one's even. But one of them has to be odd. So this is an odd even pair that eliminates one odd in that makes give us one more odd in row 5, so this must be even here. Boundary here, boundary here. This is size 2 for the evens region. Even if one of these is red, one of these has to be red, give us 7, right? We have 4, 5, 6. This must be the 7th, and it must be blocked by an even cell. So one of these is even, which means the other one is odd, and we have 4 evens already accounted for in row 6, so this must be odd. Okay. Okay, remaining digits, even digits in row 4 are 4, 6, and 8. This can't be 6 because of 6 in the column. We have a 4, 8 pair in row 4, which eliminates 4 and 8 in the rest of the row, so this is 6. This then has to be 4, 6, or 8, but no 4 here because of 4 in the column. No 8 here because of 8 in the column. Remaining digits of column 7. We have 4, 1, and 9. Okay. Um. We don't have any information about that. Okay. This is also 6 or 8. Remaining digits of column 4 are 3, 5, and 7. No 7 there because of 7 in the row. No 5 here because of 5 in the row. This is 3, 5, or 7. We have a 3, 5, 7 quadruplet or triplet in row 9, which eliminates 3, 5, and 7 in the rest of the row. So this can't be 3 or 5. It's 9, which eliminates 9 there. So that's 5. 5 eliminates 5 here, so it's 7. This can't be 7 or 5. It's 3. That eliminates 3 and 7 there, so that's 5. 7 eliminates 7 here, so it's 5. 5 eliminates 5 here, so it's 1 and 5. This is size 5, so this cannot be odd. It must be even. That gives us 4 evens in column 5, so this can't be even. This is odd. Okay. This can't be 1 or 5. It's 3. That eliminates 3 and 5 here. It's 1 and 7 as a pair. Remaining digits of row 4 that are odd must be 1, 3, and 5. This can't be 3 or 5 because of 3 or 5 in the column, so this is 1, which makes this 3 or 5 there. 9 eliminates 9 here. This has to be 4 or 8 as an even digit. Remaining odd digits in column 5 are 1, 3, 5, and 9. This can't be 3 or 5 because of 3 or 5 in the row. No 5 here, no 3 here, no 5 there. Where is the 5 in column 5? It has to be here. So this 5 eliminates 5 there, so it's 3. That 3 eliminates 3 there, so it's 7. 3 eliminates 3 there, so it's 5. We have a 1, 9 pair in column 5, which eliminates 1 and 9 in the rest of the column, so this can't be 1 or 9. It's 3. 1 eliminates 1 there, so it's 9, which makes this 1. That leaves this as a 7. 7 eliminates 7 there, so it's 1 and 7. This can no longer be 1. 9 eliminates 9 here. Where is the 9 in column 7? It must be here. So this is odd, which means the other digit must be this. Must be even here to block the odd digit. We can't have odd here because then that would be too large of a region, so this must be even, which eliminates even there, so that's odd. And that should be all the regions we have for the diamonds. This has to be 4. That makes this a 1, so this is odd. 4 eliminates 4 here, so it's 6, which makes this 8. That eliminates 8 there, so it's 4, which eliminates 4 there, so it's 8. 8 eliminates 8 there, so it's 6. 4 eliminates 4 here, so it's 8 and 4. And the rest is going to be just normal Sudoku. That makes this a 2. This must be 1 because of the remaining digits in row 5. This is even, so this is 8, which makes that a 3. 3 eliminates 3 there, so it's 1 and 3. We should have all 9 ones. 2s, we don't have enough information. Ugh. 3s, we have all 9 3s. 4s, we don't have enough information. 5, we have all 9 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6s, we have 8 6s, so we need another 6 there. That's the only place for it. 7, we have 8 7s, so we know where the last 7 is. It's there. 8s, we have 8 8s. We know where the last 8 is. It's there. 9. 9 in box 9 cannot be here because of 9 in the row. Can't be here because of 9 in the column. So 9 has to be there. That gives us 8 and 9s. We would know where the last 9 has to be. It's there. 2s then. 2 in box 9 cannot be here because of 2 in the column. So 2 is there. That gives us 8 2s. So the last 2 is there, which gives us the last 4s. And that's a solution. Yeah, I mean, fairly straightforward. The diamonds were very restricting, so it was pretty clear how you had to approach this, right? It's basically just coloring odds and evens and then counting them up, right? And figuring out which ones had to be boxed in, right? Yeah. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.